All right, here's a hint video for the back of this formative, this graphing problems and review. All right, you got to make a graph. First thing, what are our variables? Time's going to be on the x, displacement's going to be on the y. You write that out. All right, now you got to get a sense for how to set it up. I go from -50 to 80. All right, I'm just going to make this be 80 and then count down. 10, 20, 30, 40, 10, 20, 30, 40, 50, 60, 70, 80. So this would be 0. And I got to go to -50. So 10, 20, 30, 40, 50. All right? You don't have to label every increment. I'm going to make this be my x-axis. That's time in seconds. And it goes from 0 to 20. There's 20 boxes. 20. So now, at 2, I go to -25. So -2, 10, 20, that's here. Okay? Now I'm starting at -10. I'm just below my reference point. All right? And then I'm going to connect them. At 4, I go to -55. All right, now you'll notice the subtle change in slope there. All right? And then at 6, that's here. I'm going to go to -45, that's there. -35, and then -15. All right? And then you would continue it out. I left off right there. All right? Average speed from 0 to 4. All right, that's this section of the graph. All right, how far, remember it's distance, not displacement over time. Total distance and total displacement for time. From 0 to 4, my time was 4. How far did I go here? You just make these numbers positive and then subtract them. All right, your answer can't be positive. You can't have a negative, you can't move a negative distance. Now the average velocity. All right. Now, this is total displacement and total time. Now, my time is going to be the same, right? Because it's still 4 seconds from there to there. But I went negative here. From -10 to -35, so that means I went negative 45 meters. I went down 45 meters. Now, it's not negative in the sense of a lack. This negative just means like moving down. Okay, then I would divide that by the time. All right, average velocity. Remember, that's total displacement over total time, TT. Remember, with total displacement, I'm really only concerned about my first and last points. So you just compare these. How far did I go? Did I go in the positive or negative direction? You simply could connect. It's really like that. You wouldn't draw this, but that's what you're really comparing. You wouldn't draw this line on your graph, so don't do that, but that's what you're comparing. All right? Whatever that distance is in meters, I would divide that by the total time, and here's my total time. Oh, here's my total time, 20. Okay. Average speed. Now, average speed, you can either use the graph or you can use the table, and you got to chunk it out. So here, from 10 to 25, I went 15. From 25 to 30, I went 30. Here I went 20. Here I went 20, and then you're going to add those up. So I'm going to have a long list of like 15 plus 30 plus 20 plus 20. All right, and I ended right here. Keep going. Go all the way up. You can also you can chunk it however you like. You could actually go from there to there for the rest of them. All right. whatever you get, you should have a bigger number than this. You're going to divide that by 20 because that's the total time. All right? Oh, here we're going to kilometers per hour. All right? Once again, let's just say our average speed is 10 meters a second. I put that at the start, 10 meter a second. Now, remember, 1 hour is 3,600 seconds, so I always arrange the factors diagonal. All right? And 1 hour goes on the bottom. All right? There's 1,000 meters in 1 kilometer. Here's my meter. So my meter is going to go here, so that's going to go there. My km is going to go up top. How many times does the object accelerate? Ooh, subtle difference. How many times? You'd have to count them. All right? Remember, anytime the graph changes slope, it's accelerating. So here's 1 right there. 1 because it gets steeper. 2, 3, all right? And you're going to tally them. The evidence has to do with the slope. What does the slope do? So on number 1, why is 1 negative and one other not? Well, remember, one's a speed and one's a velocity. Okay? When is the object moving fastest? How do you know? That has to do with slope. When the slope is either like this or like this. Is it A or B? All right? When does the slope look like this? Does that slow or fast? B. All right, you're not choosing between A or B here. Okay? You're choosing from a section of the graph. And when it says when, you could say like from blank to blank. So from a time period, from like here, I'm just going to go 6 to 8. That won't be your answer, but from like 6 seconds to 8 seconds would be a good way to state when. Okay? And then how do you know? Because talk about slope.